Okay, sorry, I didn't start the stream for YouTube, so we are going to start again. I'm really sorry. So we are talking about searching, sorting and sliding. So then we were talking about the schedule. So we are going to be covering the basics of sorting, searching and sliding window for 13th and 15th for the next sessions. We'll be solving the problem set from today. So today there was a problem set. If you didn't check it out, go to Discord and check out the message Pallavi ma'am sent. So she gave the link for the Unacademy quiz. And then, if you need to know about arrays. So arrays are a collection of elements, and if you say the elements are 1, 4, 3, 6, 2 and 0, the indices will be 0, 1, 2, 3, 4 and 5. So 1 has an index of 0, 4 has an index of 1 and so on. So as you can see, the index 0 is for the first element. So it's 0 based index. So it starts from 0. Usually in real life we'd say first element has an index of 1, second element has an index of 2 and so on. But in programming it's not like that. Index 0 is for the first element, index 1 is for the second element and so on. And in today's session we are definitely going to be using 0 based indexing, and we are not going to be using 1 based indexing. So please note that. So just to test your understanding of arrays, here's the question set. So what is the element at index 3 in the following array? Let me create a poll. And so actually, let the poll finish. Yep, so the answer is actually 7, because as I said, the index is 0 based. So it's 0 is 5, 1 is 3, 2 is 6 and 3 is 7, and therefore the correct answer is 7. It's not 6 as in 1 based indexing. So as I said, we are going to be using 0 based indexing, so the correct answer is 7. And then here's another problem. What is the first index where 7 occurs in the following array? So let me create another poll. Yep, congrats Manan for getting first both times. So the answer is actually D, because as I said, this is the same as this. So it starts at 0 and 1, 2 and 3. So the correct answer is D. And let's move on to the next topic. So searching. So searching is what we use every day, almost every day. So whether it be searching to Google for some information that you want, or searching in a library for a book that you want, or searching for an item in a shopping mall, searching is the same thing in programming, but it's a bit more systematic. So that's why programming has a specific topic called searching. And now there are some searching algorithms which you can use to do it better. So search faster, search better and use a better approach. So some of the basic ones are linear search, binary search and sliding window. So first we are going to be talking about linear search. Linear search is what we use every day. So when you search for an element, you scan through the elements one by one. Say there are 1, 2, 3, 4, 5 and you want to find 5. You'd search for 1 and 2 and 3 and 4 and then 5. That's what searching is. So you search through elements one by one. So that's what linear search basically is. Is using STL a good idea for IOI? Yes, it's a really good idea. You need STL actually. STL is very important. So say you are searching for a book, you can scan through the books one by one until you find the book that you want. So this is linear search. So now we are going to be talking about how we can implement this in programming. So implementation of linear search. So if you say you want to print the elements in an array, for element in array, print the element. So this is how you can print the elements of an array. So if you want to take the sum of the elements of an array, use sum equal to 0. So initialize sum equal to 0, and then for element in the array, add that element to the sum. So this is how you get the sum of an array. So we'll take another example. For example, if you want the max of an array, how will you get the max of an array? So initially, initialize max as negative infinity. So this will make sure that any value that you choose will definitely be the max. So if it was negative 5, then negative 5 is greater than infinity. So any value will definitely be greater than negative infinity. So this is why we initialize max as negative infinity. And for element in the array, we are going to make sure that max equal to the max of element or max. So we are going to take which one is larger. So this makes sure that a max is greater. Max is always the greater, and we take element or max. So yeah, now this is how we get the max of an array. So the answer is the max. This is how linear search can be used in other ways. And let me jump back. Yeah, so this is how we can use implementation of linear search. Now the time complexity of linear search. I am pretty sure Aryan taught you how time complexity works in the intro to algorithms classes. If you don't know how time complexity works, you should go check out his lesson. So linear search takes O of n time because there are n elements. Say there are n elements, and each of the elements will be gone through n times, one time. So the total is O of 1 into n. So one constant time into n times, which is O of n. So this is the time complexity of linear search. And then binary search. So now this is one of the most, some people think this is really complicated, but this is not actually complicated. This is very, very simple. We actually use this intuitively in our everyday life. So without even realizing it, you are using it right now. So say you have a library again, let's take the library again, and there are the books in the library are sorted in alphabetical order. So it's first A and then B and so on to Z. Also like searching in a dictionary, yeah, that's right. So say there are books with label A, B, C to Z. So if you want to find a book E, for example, first of all, let's take a smaller example. Let's say A, B, C, D, E, F, G. So this should be enough. Say we want to find E. How do you find E? So now take the middle element. So if the middle element is smaller than E, that means that since this is sorted in alphabetical order, you definitely know that any value to the left of D will definitely also be less than E. So if D is less than E, that means that A, B, C are also less than E for sure. So we can cancel out this part completely. So this place will definitely have values that are lesser than E. So then you take the rest of the elements and you want to find E in the rest of these elements. So you check F. F is greater than E. So you know that F is greater than E, and any values to the right of F will also definitely be greater than E. So since E is greater than, E is less than F, that means that G is also greater than E. So if E is less than F and F is less than G, E is also less than G. So you can cancel out F and G. So you have the element right now. So this is how this works. This is how binary search works. It's very simple and very intuitive. So let me show you guys an example. So compare middle element with the target. So this is the first step in binary search. So say you have a list of elements, you compare the middle element to check which side will be eliminating right now. So compare middle element with target. If the middle element is smaller, remove the left side of the array. So if the middle element is smaller, so that means that the target is in this side, target is in the right side. So the left side will, if the middle is lesser, then the left side is also lesser. So this whole part is cancelled out, and then now we have to check for the right side and repeat this on the right side. So say in this case, no, this was greater. So the middle was greater. If the middle is greater, then you cut out the right side. So this is how binary search works. And if it's equal, then you have two choices. You can instantly print it out. So if the middle is equal to the value, if the middle is equal to the target that you are looking for, then you can just print that index. Right. So otherwise, if you want the leftmost value, I'll be talking about that soon. So did you guys get how binary search worked? So if you guys did, then go ahead and give up a thumbs up. Okay, cool. So I guess all of you understood, and you are following up, right? You understood everything from this part, right? If you didn't understand, feel free to ask questions, or feel free to say, that I didn't understand. I'll go back and review it. If anyone didn't understand, just say so. It is the same as merge sort. No, merge sort is vastly different. Merge sort is actually vastly different. Will you be discussing the practice test questions? Yes, I will be discussing the practice test questions. If I have time, I will definitely discuss them in the next session though. Don't worry, I will definitely discuss them. You guys are mocking me. Okay, so let me go to the next part. Time complexity of binary search. So binary search takes O of log n base 2. So let's see how this is true. So let me jump up to the empty okay, so basically each time you have an array like this, and say this is some large array, each time you are eliminating half of this array. What is the best searching algorithm? It's actually, depends on the situation. So binary search doesn't work in case of unsorted arrays, so you can't say that anything is the best searching algorithm. So now say you have some large array with some elements, so it has some elements, and at each iteration notice that you are eliminating half of the array. You always know that left is not valid or right is not valid, so you can always eliminate half of the array, right? So you can always eliminate half of the array, which leaves you with, so say there's some n, so then each time you are dividing it by 2. This is n by 2 by 2 by 2 and so on, right? So if you guys got this, then we can move on. Okay, I guess you guys got this, so let's move on. So this is n by 2 power k. So say k is some value such that n by 2 power k is equal to 1. So if we estimate it to be 1, then 2 power k will be equal to n. So 2 per k equals n, that means, 2 per k equals n, and that means that k is the number of times you iterate. So if you iterate for k times, you divide it by 2 per k. So k equal to, now 2 per k equal to n means, if you know basic algebra, then this is log n base 2. So this is why the time complexity of binary search is log n. So if you divide it by k times, so each time you are removing half of the array, and so it will, it will divide by 2. So the n elements are divided by 2 at each time. Okay, so I hope everyone got that. If you didn't get it, please say so and I'll revisit it. Okay, I guess everyone got it. Why did you put n by 2 per k equal to 1? Because if n by 2 per k is not equal to 1, so n by 2 per k is something like 2. That means you have 2 elements left to search. So say you have some array like this with 3 elements, and you are dividing it, say 4 elements, and you are dividing it by 2. So n by 2 is equal to n is equal to 4, so 4 by 2, and that is equal to 2. That means after eliminating half of the elements, you still have 2 elements left. If you want the answer to be exactly equal to 1 element, then you have to binary search till where the size of the array is equal to 1. So if the size of the array is equal to 2, for example, then you don't know which side it is on. So you don't know whether the first element is the value or the second element is the value. So that's why you iterate till n by 2 per k is equal to 1. Did you get it? Oh, okay, great. That's great. And Aryan, can you please stop? Okay, so let's go back. And binary search takes O of log n time, where n is equal to the number of elements in the array. So we eliminate half of the array in each iteration. Okay, but the reason why binary search is so fast is that 10 power 18 elements, which is huge. Like 10 power 18 is 1 followed by 18 zeros. So this huge number can be covered in just 64 iterations. So you can basically work it out by hand. So that's why binary search is so fast. But linear search isn't that fast because it has to go through each element. So linear search will take 10 power 18, while binary search just takes 64 at worst case. In the worst case, it takes 64. Well, that's just that's just some approximation. You are right technically, 60 iterations, you are right, but this is just an approximation. You are using 64 because we can estimate it such as L long. So L long is actually equal to 2 power 64, and this is the largest number you can get with long int in C++, but that's for another day, not today. So that's why we are going to estimate it as 64. Okay, so now let's move on to the implementation. So the implementation, and now you know that the array, half of the array is eliminated at each index, each iteration, right? But the problem is you don't know whether it's, the eliminating an array, half of an array takes too much time to do. So if you take half of the array, then the problem is, so say you have an array like this, and the problem is you have to delete each element. You have to delete this index, and then maybe this index. So this will take 3 times. So this will in the end it will be O of n. So the problem with deleting the element, so the problem with eliminating half of the array is the problem that you can't delete the elements in O of 1. So we are going to use another method. So deleting the elements is basically the same as, so let's say you have an array like this again. So if we set L equal to this index, so let's say L equal to 0. As I said, we are going to be using 0 based indexing, we are never going to be using 1 based indexing. So R equal to n. N is the value length of the array. So this is n minus 1. So you take the middle. So middle of L and R is L plus R by 2. So this is how we get the middle of two elements. I'm pretty sure you already knew that. And L plus R by 2. So we got the middle element. And how do we, how do we move the left and right? So how do we remove the array without actually deleting the elements? So how do we remove the left side? So we just set L equal to this index. So if this is 0, 1, 2 and 3. If L is equal to 2, that means that we can know the middle will always be greater than L. So R is greater than L. So L is less than R. And then the middle has to be in the middle of L and R, right? So if L is equal to 2, for example, then the middle will never be equal to any value less than L or any value greater than R. So did you guys get that? Let me erase everything. So okay, so I guess everyone got it. If you got it, react with thumbs up. If you didn't, react with any other emoji. So 2 people didn't get it. Oh wait, a lot of people didn't get it. Okay, let me just explain again then. So we'll be setting a left and right. L is equal to left and R is equal to right. We are just going to be writing L and R to be short. So left and right. So in this case, L is equal to left and R is equal to right. Please remember that. So we have some array, and when we delete the middle of the array, so when we compare the middle and delete one side, if we set, let me erase this part. So if we set left is equal to this index, so left is equal to middle. So initially left and right are equal to 0 and n minus 1. So this is the endpoints of the array. So this is L is the beginning of the array and R is the ending of the array. And then so we take there's some major background noise. Let me take a look. Is it fine now, or is there still some background noise? Oh, okay then. Okay, so let me just continue. And L is equal to 0 and R is equal to n minus 1. So in this case, so if we eliminate half of the array, so say we have to eliminate the left side. So this is the middle element and we have to eliminate the left side. We'll just set left equal to middle. So left equal to middle. So if you set left equal to middle and R equal to n minus 1, so in this case, if left equal to middle and R equal to n minus 1 is just the last index of the array, and we take the middle of these two. So the middle of these two is equal to L plus R by 2. So that's the average. So we get the middle now. In this case, we will be knowing that the array in the middle will never be less than L. So L plus R by 2, the average of these two elements. Why are we not taking median? Why mean? Actually there are just two elements, so there is no mean here. I mean there's no median here. So the L and R are the only values. So L plus R by 2 is equal to the middle, right? So can we take them as start and end? I don't understand what you're trying to say by that. I'm really sorry. So L plus R by 2 is equal to middle. So if we set the middle as L, so if we set L equal to middle, then we know that the left side will never be iterated again. So L plus R by 2 has to be, so by definition has to be less than or equal to L and less than or equal to R. if L is greater than R. So we know that L will always be greater than R. I mean L is less than R. L is always less than R. Yeah, there is actually one. I'll show that in the end. I'll definitely show that. Yeah, we are actually doing that. We are setting L equal to 0 and right equal to n minus 1. Abhinav, that's what we are doing. And Gaurav, I'll definitely discuss that. Sure. So now we know that L plus R by 2 is in the middle. I mean, it's in the middle of these two elements. So now we can eliminate half of the array. So we know that this part won't be the this part will definitely be, say, R equal to this and m to the middle and R equal to the n. So in this case, if L is some value that is not equal to 0, and that means that any value less than R, any index less than L will definitely not be iterated through. Since the middle will always be between these two elements, we know that the elements below L will always be in the middle. So now we can do the same for R. So I will discuss that in an empty slide. So if we take L is equal to the middle, then R equal to here, then the middle is somewhere around here. So this part won't be iterated through. But if we set, if say we need R equal to here, and this part is eliminated by some manner, that means that the middle will not be greater than R. So the middle will always be less than R and greater than L. So did you guys get that? So if it's no, just say no in the comments. Oh, you didn't? Okay. Okay, let me start from the beginning. So L is here and R is here. L equal to 0, L equal to the middle, L equal to the beginning of the array and R equal to the end of the array. So I hope you got that. And if we set L equal to the middle, or let's first say L equal to the middle. So this is the middle and we set L equal to middle. In this case, the middle will be L plus R by 2. Right, I hope, did you guys get that? So the middle will be L plus R by 2. The left side plus the right side divided by 2 will be the middle. That's actually the average of the two elements is the middle. So now when we know that on that cause, let's first talk about this. And now we know that the middle will be, say the middle is less than the target. Say the target is equal to T and the middle element is less than target. So the middle element is less than target. So we know that the left side won't be the target won't be in the left side. So we just set L equal to M. So the new middle will definitely be greater than L. So this side, the new middle won't be on this side. So this side is completely eliminated and the new middle will be somewhere around here. So now, and in this case, so let's say M is greater than, this is T actually, this is T. M is greater than T. And if M is greater than T, then we know that the right side won't be equal to the element. So the right side won't contain the element because M is greater than T. So if the middle is greater, that means the right side will definitely have more greater elements, which should make it even greater. So R equal to the new middle. So R equal to some value and M equal to some value. So notice that L plus R by 2 will never iterate through the same index again. So now we eliminate half of the array, and when we set the middle, it definitely goes away from that. So if when L equal to M, that means that L equal to 0 will never be iterated through again, and this part will never be iterated because L is equal to middle and any value greater than middle will be the new middle. So That's binary search basically. So is on. So basically we are eliminating the elements without deleting the values. We are just using left and right to indicate the parts that we have already iterated through. So we are just not deleting. That's basically what we are doing. Okay, I guess everyone got it. If you didn't, please say so. Just got it. Okay. So let me go to. So this is the implementation of binary search. So we are going to be testing your understanding on binary search. So how many times does the above binary search implementation iterate to find 5 in this array? So will it be 2, 3, 4 or infinite loop? This is the array and this is the implementation. So just take a pen and paper and just write this out and delete it and just do it. You can just simulate it, so you will know which value it exactly is. So we will be updating the mid value to the left or right according to the satisfying condition. Yes, exactly. So if the middle is lesser than the value, then that left value, okay, so monitor, oh I didn't, wow, how can iteration be defined as? Okay, so actually, so iteration can be defined as it's just an element. So it's just iterating through the items, traversing through the items. Say you have 1, 2, 3, 4 and 5. Going through the elements is the exact word for iteration. So iteration means first checking 1, then 2, then 3, then 4, then 5. So it's the number of time a loop occurs. So let's say a loop, there's a for loop, and the body, this is the body. The number of times this has happened is the iteration. So let me just search up the exact meaning. Okay, so according to Google, it is equal to the repetition of a process or utterance. So that's what iteration is defined as. What happens when element is not found? When the element is not found, you can actually get a wrong answer. So when an element is not found, there is actually a way to find that, and I will discuss that. Okay, I will discuss that. Yeah. Yeah, most of the times we are asked to return -1. Yes, I will discuss that actually. I forgot that case. So. Oh, sorry, I have to start a poll. Well, I just showed the answer, so maybe not. So the answer is 3 because first of all we are going to be taking the middle. So we are going to be taking 4, and the left side is the target was 5. Remember that the target was 5. And left is equal to how to tell the number of times an array has been iterated. So the number of times a loop has been repeated is the number of times the array has been iterated through. So the left is equal to, okay, I will discuss this code again. So while left is less than right, so in case left is equal to right, in this case left is equal to right. Oh, okay, sure, I'll do that now. I'll just erase all. So if L is equal to R, that means that the middle is also equal to L, right? So this is L plus L by 2. So if L is equal to R, then instead of R we can substitute R as L, and L plus L by 2 is still equal to L, right? So that means that we have reached the final element. So yeah, that's what left is less than right means, and middle equal to floor left plus right by 2. This case we are taking the the lesser values. So floor basically means that 2.5 turns to 2. 2.5 equal to 2 and 2 is still equal to 2. But 2.7 is also equal to 2, and any value we are just taking the integral value. So 2.7 is also equal to 2. So this is what middle is. So we are taking, if there are 4 elements for example. So I am first actually revisiting the code. So say there are 4 elements and you have to take the middle. So L is equal to 0 and R is equal to 3. So 0 plus 3 by 2 is 1.5. And we are taking this value because, well, we can just take this value, so that won't hurt. Yeah, so middle is the floor of these two, and if array of middle, so if the middle element is less than the target, then the left has to be the left bound, so we can call it as a bound. So this part we know has been eliminated. So left equal to middle plus 1. So since this is smaller, we definitely know that this will be greater, the left value will be greater. So if the value is equal to, array of middle is equal to target, that means that we will be reaching this condition. So we will be reaching this condition if the array of middle is greater than or equal to target. So if the middle element is actually greater, that means we are going to be setting right as this value and we are going to be setting left as the middle otherwise. So this constrains the value where middle can go. So if say this is the array and there are some elements here, and L is equal to this value and R is equal to this value, and the middle will definitely not be less than L or greater than R. So the middle will always be here. So if the middle value is less than the value, that means that we can go to the next element. For example, in this array we know the middle is less than, so 4 is less than 5. In this case 4 is less than 5. So in this case the left value has to be from 5 and the right value has to be here. So L and R are these values. So we basically just reduce the array to 5, 8, 9. So 5, 8, 9 is the new array after deleting the elements but without removing them from the array. So now if we take the middle element again, so middle will be here. So this value will be equal to, so this will be 5 is less than or equal to 8. So this condition is true, which calls this condition. Array of middle is 8 and 8 is greater than or equal to 5. So since this is true, we are going to be setting the middle as, the rest, we are going to be setting right as the middle. So we know that this is 9 is not the value for sure. So R is going to be here. And now we are going to be taking the middle again. So the middle will be 5. So L plus R is 0, 1, 2, 3, 4. So 4 plus 5 by 2, which is equal to 4.5, but we are going to floor it, so it is going to be equal to 4 actually. So 1, 2, 3, 4, 0, 1, 2, 3, 4. So the fourth index is 5. So since 5 is greater than or equal to 5, again this condition will be called. So this condition will be called and right is equal to middle again. So right is equal to middle. So middle and L are in the same position. So now after setting right equal to middle, so middle, L and R are all going to be the same value. So now this condition fails. So while left is less than right, so left is less than right is false because left is equal to right. Sorry. And so we know that the index is equal to 4. So left is equal to 4, right is equal to 4, and therefore the index is equal to left. So index is equal to left, so the answer is equal to 4. So at index 4 we can find 5. So sir, there are more than one element which can be selected as middle, then which? If there are more than one element of the same type, you mean? So if there are 5, 5, 5 3 times, you want to know what will happen in that case. Oh, okay. In that case, since this value is greater than or equal to 5, so we'll take the middle. So let's just say this array is 5 comma 5 comma 5 is the array. 5 5 5 is the array, and now we take the middle element. Won't your loop get stuck in some cases? Actually no, it won't. So 5 comma 5 comma 5. So the middle element is 5. So this is greater than or equal to 5. The target is also 5, and by this case array of middle is what is the answer? And then I am assuming that there will be an element. There is 5 in this array. So if there isn't, then the answer might be wrong. So array of middle is equal to 5. So since the middle element is 5, we are setting array of middle is 5 is greater than or equal to target. So the target is also equal to 5, and in this case right is equal to middle. So right will be set as this value. So this is right and this is left, and take the middle element again. So middle element again is 5, since this is 0 plus 1 by 2. The middle element is all again equal to 0. So this is also 5 is greater than or equal to 5, in which case L will be set as, R will be set as middle. So middle is 0. So L equal to R equal to 0, and therefore this condition fails. This condition fails again, and you get the leftmost value. So that's what we are aiming for actually. We want the leftmost value. This following binary search implementation finds the leftmost value, the first occurrence of an element. So actually this is another part of a question. I am going to ask the next question. So did you guys understand this part? Okay. Okay, so you guys understood how this binary search works, right? If you didn't, please don't hesitate to ask. Okay, so now this is the next problem. How should you change the above implementation such that the final index would be the last occurrence of the element? So in this implementation, you want to change it such that it finds the last occurrence instead of the first occurrence. Now we are finding the first occurrence. How will you change this following code such that the final value is the last occurrence? So just answer in the comments. I'll give you a few minutes. So and yet again Manan is correct. Manan is correct. So that's also correct. Bino Manjesh is also correct. So both of these people are correct. If array of middle is less than or equal to target, first of all remember that left is equal to right. So index can be equal to left, which is also equal to right. So saying that the answer is right will be the same as index equal to left. Index equal to right and index equal to left are both the same thing, because while left is less than right, this will be executed. So in this case left and right are the same value. So you have to change a value inside the code. And Gaurav says array of middle is less than or equal to target, left equal to middle plus 1, and array of array or middle less than target. Actually Gaurav, you are really close. Gaurav is really close. So basically there's another thing you should change. So Manan is right. So first of all this will be middle minus 1 and this will be removed. So in this case what we are doing is, so this is less than or equal to and this will be removed. This will be greater than for sure. So in this case, if array of middle is less than target, so say there's an array with elements 1 1 1 you want to find the say this so in this array you want to find the last occurrence of 3, for example. So the last occurrence of 3, how do we find that? So first of all, we'll take the middle. So we'll take the middle, and left is equal to 0 and right is equal to n minus 1. N is equal to 1 2 3 4 5 6 7. 7 minus 1 is 6. So r is equal to 6. R is equal to 6, and then the middle will be L plus R by 2, which is middle. So this will be the middle, and middle is equal to 3. Now take the seal. So instead of the floor value, take the greater value. So L plus R by 2, seal of L plus R by 2. So this is how you get the max. And now when L is now the middle element, the target was 3. Remember that we want to find the rightmost occurrence of 3. So if array of middle is less than target, so target is actually equal to 3. So an array of middle also equal to 3. So 3 is less than 3 is false. So 3 is less than or equal to 3 is true. So left equal to middle. So we are going to be setting middle as m. So we are going to be setting middle as m. Middle as L. Sorry, middle as L. So L is equal to 3 because 3 is less than or equal to 3 is true, and left equal to middle. And this part of the array will be eliminated. And we are going to be taking the middle again. So the middle is 3 plus 6 by 2. 3 plus 6 by 2 is, in this case, 9 by 2 is 4.5. And for 4.5 we are going to be sealing it. So this will be seal. So seal will do the opposite of floor. If it's 4.5, then it will give you 5. So it will give you 5, it's 4.5, and if it's 4, it will still give you 4. And then the middle is equal to 5. So now 4.5 seal is 5. So 0 1 2 3 4 5. So we'll be taking this as the middle, and we'll be checking if this is greater than or equal to, less than or equal to the array of middle. So array of middle is 5, and 5 is less than 3 is false, and less than or equal to 3 is false. So this condition will not be executed. Remember that this condition will not be executed, but this condition will be executed because array of middle is greater than 3. So 5 is greater than 3. So this condition will be executed. Right equal to middle minus 1. So middle is equal to 5. Remember that 4.5 sealed is 5. Seal is actually denoted like this. So r is equal to 5 minus 1. So we definitely know that this is not any value greater than or equal to r. So we are going to be setting this as r equal to 4. And now we take the middle again. So the middle is 3 plus 4 by 2. 3 plus 4 by 2 is 3.5. So 3.5 sealed is 4. So this is the middle right now. So this is the middle. And now we are going to be setting this as L equal to, since this is greater than, less than or equal to target, L equal to middle. So middle is equal to 3, middle is equal to 4, so this is equal to 4, and r is also equal to 4. And now this condition is false. So since this condition is false, we instantly break out of the loop, and index equal to left. And when index equal to left, it is equal to 4. So 0, 1, 2, 3, 4, and we got the right element. So this is the rightmost occurrence of that element. So did you guys get this? Okay, I guess most of you got it. If you didn't, ask me in the Discord after a bit. So I'll be in the Discord. I'll answer all of your questions. So what is my Discord username? I'll type it here. So if you guys have any questions, do ask me there. And so if you have any questions, feel free to ask right now. You are trolling me. You are actually trolling me, are you? So do you guys have any questions? If you have questions, do ask. I'll be free right now and I'll answer all of your questions. So for the people who clapped, yes, how can I contact you? As I said, my Discord username is Sriv #5123. So you can contact me via Discord. And if nobody understood, please let me know. Yeah, today this session is over for today, and we'll be continuing. Yeah, we will. We'll be continuing research. Thanks a lot, and do give me your feedback. You are in this link, so I'll type it out. So you guys can give me your feedback here. I'd appreciate it a lot. No problem. So do you guys have any other questions? Is sliding for the last lecture? Yeah, we'd hope. I'd say sliding will be for the last lecture. Question tab. Okay, I keep forgetting that. If we interchange the value of left and right in the start, will it give the last? So will that give last occurrence? Actually, this is not the case. So if we interchange the value of left and right, this might go wrong. So let me show you an example for just in case. So 1, 2, 3, 4 and 5. So we'll say R is equal to 0 and L is equal to n minus 1. So in this case, as you can already tell, this is going to be a bit wrong. So when if we take the middle, say we are searching for 4. So when we take the middle will be equal to 3. So 3 is less than 4. So we are going to be setting LR as this value and L is equal to n minus 1. And this will actually give you the same result as the previous one. So this won't change a single thing. You're just changing the value of R and L. So you're just changing the variable name. So the changing the variable names is going to do nothing. It's going to change nothing actually. So I hope that gave you the answer. So can you please share some practice problems on SSS? Sure, I'll send it to you soon. I'll send it to you in Discord. So since we are running low on time, I'll send it to you on Discord soon. So okay, then I guess that concludes today's session. I'll continue this session on day 13. So 13th. Bye guys, take care.